Caribbean waters reach dangerously warm temperatures as a tropical wave approaches. Experts warn actual development chances far exceed the 30% official forecast. The Caribbean region currently faces elevated possibilities for tropical formation, with ocean temperatures reaching exceptionally high levels. Official forecasts indicate a 30% probability, though meteorological experts suggest actual chances may exceed this figure. The challenge lies in the extended time frame involved. While standard outlooks cover 7 days, this particular weather pattern could persist considerably longer, potentially stretching beyond 2 weeks. Current satellite imagery reveals a pronounced atmospheric disturbance moving westward across the Atlantic. This tropical wave shows a distinct bend in wind patterns, clearly visible on space-based photography. The moisture concentration appears heaviest in the central portion of the system, with surrounding areas showing variations in atmospheric moisture levels. Development probabilities remain modest at 10% for the next 48 hours as the disturbance approaches eastern Caribbean territories. Hostile upper atmosphere conditions and substantial dry air pockets currently inhibit organization. The system must navigate through these unfavorable elements before reaching more conducive environments. However, once positioned within the Caribbean basin, atmospheric conditions become significantly more favorable for strengthening. Multiple forecasting models paint diverging scenarios for this weather pattern. The European computational model suggests gradual westward movement through midweek, with minimal organization initially. By weekend timeframes, intensification possibilities increase substantially as the system enters the Western Caribbean zone. Meanwhile, a separate meteorological feature, BMD, a broad circulation over Central America, commonly termed a gyre, adds complexity to predictions. This spinning atmospheric pattern, similar to formations that spawned previous significant hurricanes, could capture and enhance the incoming disturbance, causing it to linger for extended periods with limited directional movement. Forecast consensus, combining European, American, and artificial intelligence models from technology companies, suggests approximately 40% probability for development somewhere within the Caribbean. 2 distinct pathways emerge from ensemble data. The first scenario involves northward recurvature toward Hispaniola and Puerto Rico territories, carrying roughly 16% probability based on model member counts. The second pathway keeps the system confined to Western Caribbean water, where it would drift with minimal steering influences. The critical factor determining which path materializes involves jet stream configurations over North America. A powerful atmospheric trough currently positioned over the eastern Atlantic cannot influence the weak tropical system at present. However, subsequent jet stream undulations arriving midweek will prove decisive. Should the system strengthen sufficiently when the next atmospheric dip approaches, it could be captured and steered northeastward toward Greater Antilles Islands. Conversely, if the disturbance remains weak during this crucial window, steering currents will remain insufficient, allowing westward drift to continue. Atmospheric patterns then flatten across the region, leaving the system essentially stationary in Western Caribbean waters near Central American coastlines. This stalling behavior could extend throughout the following week, with development occurring slowly over exceptionally warm waters. The overall probability of the system surviving its initial journey across hostile conditions and reaching the Caribbean in viable condition stands near 50%. An entirely separate weather feature occupies the northern Atlantic near the Gulf Stream current. This non-tropical system, spinning vigorously off the eastern seaboard near Canadian maritime provinces, contains winds approaching 50 to 60 miles per hour. A frontal boundary remains attached, marking its non-tropical character. However, positioning over the Gulf Stream's warmth during upcoming days provides opportunity for subtropical transition. Should this occur, naming would happen immediately, given existing wind speeds. This transformation window remains narrow, though, lasting only through the weekend before the system moves over colder waters farther north, ending any development prospects. Understanding the Central American gyre becomes crucial when analyzing late-season tropical development. This broad counterclockwise circulation represents a monsoonal low-pressure feature that typically emerges once or twice annually, most frequently during late spring and early autumn months. The gyre spans hundreds of miles, potentially covering portions of the eastern Pacific Ocean, southern Gulf territories, and western Caribbean waters simultaneously. Its weak but expansive circulation moves slowly across Central America, often persisting for days or even weeks. The gyre functions as an atmospheric incubator for tropical cyclone formation. Smaller vortices rotate within the broader circulation, creating localized areas of concentrated spin and thunderstorm activity. These smaller circulations often result from interactions between the gyre and passing tropical waves. When environmental conditions prove favorable, one of these vortices may consolidate into a tropical cyclone and eventually detach from the parent gyre. Statistical records indicate this occurs approximately once every other year, with tropical cyclone development accompanying roughly half of all gyre formations. Historical precedent demonstrates the gyre's significant role in generating impactful Atlantic hurricanes. Hurricane Michael in late 2018 exemplifies this pattern perfectly. After spending several days embedded within a Central American gyre, a disturbance on the northern periphery became a tropical depression. 3 days later, that depression had separated from the gyre and intensified catastrophically, ultimately slamming into Florida's panhandle as a devastating Category 5 hurricane, with sustained winds reaching 160 miles per hour. Similarly, tropical storms Amanda and Cristobal both developed from gyre activity during 2020, with Amanda forming in the eastern Pacific while Cristobal emerged in the Gulf region. The positioning of tropical cyclone genesis from these gyres presents substantial forecasting challenges. Prediction accuracy beyond 2 days remains limited due to the complex interactions between the gyre's broad circulation, passing tropical waves, and varying atmospheric conditions. Computer models, particularly the Global Forecast System, operated by national weather centers, historically overestimate tropical development associated with gyre activity. This tendency toward false positives stems from the inherent complexity of these weather patterns and the difficulties in resolving small-scale features within the broader circulation. Regardless of whether tropical cyclones form, Central American gyres pose significant flooding threats to populated regions. The persistent, slow-moving nature of these systems allows prolonged periods of heavy rainfall over the same geographic areas. Pacific-facing coastlines of Mexico, Guatemala, El Salvador, Honduras, and Nicaragua frequently experience torrential downpours when gyres become established. 7-day rainfall accumulations can exceed 14 inches in vulnerable locations, triggering life-threatening flash floods and catastrophic mudslides across mountainous terrain. October weather patterns introduce considerable uncertainty compared to earlier hurricane season months. By this stage, tropical cyclone formation shifts primarily toward the western Caribbean, Bay of Campeche, and southern Gulf waters. The classic Cape Verde systems that dominate peak season become increasingly rare. Upper-level westerly winds strengthen considerably, and cold fronts begin penetrating farther southward toward Gulf regions. Cool air masses rapidly decrease ocean surface temperatures across northern zone. These transitioning atmospheric conditions create an environment where prediction becomes substantially more challenging. Historical climatology reveals October as the third busiest month of Atlantic hurricane season, despite declining overall activity compared to September's peak. The month averages 5 hurricanes and 5 named tropical storms, based on century-long records, translating to approximately 20% probability of experiencing hurricane-force winds across Caribbean waters. This represents a significant decrease from September's 58% risk, yet remains notable enough to warrant continued vigilance. South Florida faces elevated risk during October compared to earlier months, as hurricane tracks tend to shift southward. Between historical records spanning more than a century, Florida endured 7 major hurricanes during October, with 5 of these striking southern portions of the state. Famous October hurricanes include Michael's unprecedented assault on the Panhandle in 2018, Opal's strike near Pensacola in 1995, and numerous earlier systems that caused extensive damage across different regions. Hurricane Sandy in 2012 stands as perhaps the most infamous October Atlantic hurricane in recent decades. Sandy, developed in the western Caribbean during late October, tracked northward across Cuba and the Bahamas, then executed an unusual westward turn toward the mid-Atlantic coast. The storm transitioned into a massive hybrid system that produced hurricane-force winds across unprecedented geographic areas. Sandy's impact resulted in more than $68 billion in damages, ranking as the second costliest hurricane in United States history. Hurricane Wilma in 2005 holds the distinction of being the most intense Atlantic hurricane ever recorded, with central pressure plummeting to an astounding 882 millibars. Wilma's explosive intensification proved extraordinary even by hurricane standards. The system strengthened from Category 1 to Category 5 status within just 24 hours, with maximum sustained winds reaching 185 miles per hour. This rapid intensification rate established records that remain unbroken. Wilma eventually devastated portions of Mexico's Yucatan Peninsula before crossing into the Gulf and making a sharp right turn toward Florida's western coast. Earlier October hurricanes have likewise demonstrated the month's potential for producing dangerous systems. Hurricane Matthew in 2016 caused extensive destruction from Caribbean islands through the Carolinas. Hurricane Mitch in 1998 became one of the deadliest Atlantic hurricanes ever recorded, with catastrophic flooding and mudslides across Central America claiming thousands of lives. Hurricane Hazel in 1954 struck near the North Carolina-South Carolina border with sustained winds of 140 miles per hour, then maintained hurricane-force winds deep into the Appalachian Mountains, a rare feat for inland hurricane intensity. The current atmospheric setup shows remarkable similarity to patterns that produced several of these historical events. Climate Prediction Center outlooks suggest low to medium risk for tropical development across the Caribbean during the next 2 weeks, with highest probabilities focused on Western Caribbean and Southwestern Gulf regions. Their hazard assessments indicate 40 to 60% chances for tropical depression formation or stronger development in these vulnerable zones. The Madden-Julian Oscillation, a large-scale atmospheric wave that propagates eastward around the equator, currently approaches the Atlantic Basin. This oscillation influences cloud formation and rainfall patterns across tropical regions. As it moves through the Caribbean zone, conditions for tropical development may improve substantially. The oscillation's passage coincides with the potential formation of the Central American Gyre, creating a scenario where multiple favorable factors align simultaneously. Wind shear, the change in wind speed or direction with height, currently remains modest across much of the Caribbean. Lower shear values allow tropical systems to maintain vertical structure and intensify more efficiently. Combined with record-warm sea surface temperatures persisting across Caribbean waters, the thermodynamic environment strongly supports tropical development, should atmospheric dynamics prove favorable. Model guidance continues evolving as new data becomes available. Ensemble forecasting systems, which run multiple simulations with slightly different initial conditions, show considerable spread in potential outcomes. This diversity reflects genuine uncertainty in how various atmospheric features will interact during coming days. Some ensemble members depict robust tropical development leading to significant storm formation, while others suggest the disturbance dissipates before reaching maturation. The progression from tropical wave to organized system requires multiple conditions aligning favorably. Sufficient ocean heat content must extend to adequate depths below the surface. Atmospheric moisture needs to reach saturation across a deep layer. Vorticity, BSBSP, the rotation inherent in the atmosphere. BSBS must concentrate sufficiently at lower levels. Wind shear must remain weak enough to avoid disrupting the developing circulation. These requirements explain why many disturbances fail to develop despite appearing promising on satellite imagery. Current observations place the primary disturbance approximately 1,000 miles east of the Windward Islands. The system continues producing widespread showers and thunderstorms, though organization remains limited. Movement proceeds westward at 15 to 20 miles per hour, consistent with typical tropical wave motion. Heavy rainfall and gusty winds will impact the Windward Islands during the upcoming weekend, regardless of whether tropical development occurs. These islands should prepare for potential flooding even without a named system. Residents across potentially affected areas should review emergency preparedness plans and ensure supplies remain readily available. Hurricane season extends through November 30th, meaning 2 months of potential activity remain. Complacency during late season proves dangerous, as October and November storms can intensify rapidly and follow unusual tracks compared to typical summer patterns. Forecasters emphasize that multiple days remain available for monitoring these situations as they evolve. No immediate threats exist to populated land areas, providing time for systems to become better defined before coastal preparations become necessary. However, the combination of warm waters, potentially favorable atmospheric patterns, and the climatological tendency for late-season development warrants heightened awareness across Gulf and Caribbean regions. October unpredictability strikes consistently each year, with systems potentially veering in unexpected directions rather than following climatological norms. The interplay between tropical systems and mid-latitude weather features creates scenarios where forecasting becomes exceptionally challenging. Tropical cyclones may accelerate rapidly northward if captured by approaching cold fronts, or they may stall and drift aimlessly for extended periods if steering currents collapse. Advanced forecasting tools, including artificial intelligence models from technology companies, now supplement traditional numerical weather prediction systems. These AI models analyze vast quantities of historical data to identify patterns that might indicate future development. However, even sophisticated machine learning approaches struggle with the inherent complexity of tropical cyclone formation and track prediction, particularly during transitional months when atmospheric patterns shift rapidly. Current situation demands continued vigilance without immediate alarm. Forecast confidence will increase substantially during coming days as the tropical wave enters the Caribbean and environmental conditions become more clearly defined. Until then, multiple scenarios remain plausible, ranging from complete dissipation to significant tropical cyclone development. Continued surveillance will clarify which possibilities materialize as the week progresses toward its conclusion.